Hi, this is Mr. Bordelon, and today we're going to talk about scarcity, opportunity cost, and the production possibilities curve. So, these concepts are related through the PPC, and the PPC itself ultimately demonstrates these two concepts. So, I want to, kind of clarify what they are because they are similar but and related, but there are significant differences. So, first off, when we talk about scarcity, scarcity is a limited amount of resources to meet an unlimited amount of needs and wants. So the limited amount of resources idea, I think, is pretty straightforward. We live on Earth. There's a limited amount of stuff that we can use to make goods and services. So we don't really have to belabor that too much. But the other side of this is the unlimited amount of needs and wants. And that's where I want to go into a need, and what a want is. Now, a want basically is, any kind of dream, desire, or wish. And I think that's pretty straightforward. We want to have a lot of time to, do painting, to go out and see as many movies as we want, to play as much Call of Duty one might, possibly want to do, or anything like that on that end. For a need, this is much more basic. Anything that's required for life. So, water, food, shelter, that kind of thing on this end. But the question is, well, how is this unlimited on this end? Are humans just greedy in some form? Well, no, not exactly. Tell you what, let's take water for an idea for a moment. All right. So when we talk about water, we need that to live. Now let's assume that we need a gallon a day in some form to live. So let's say that's 365 gallons. Now, if you're watching this and you're one of my students, you're probably 17, 18 years of age. So the average American male or female lives to be 77, 78. So let's say that you're going to be, in your somewhere around 70 more years to live. So let's multiply this together. 365 times 70. And I'll excuse my math here. I'm a social studies teacher, so you'll have to forgive me if I'm doing it wrong. 7 times 5 is 35, 42. It's 45, 4, 21. So I've got 25,550 gallons of water, which means that's what you would have to have, statistically for the rest of your life. So here's the deal. We're going to send you every single bit of that tomorrow, and that is all you are going to be able to have for the rest of your life. Now, no cheating in the shower or anything like that, or trying to get water from a lake. You're going to get 25,550 gallons of water, delivered to you tomorrow. Now, if you're uncomfortable with that amount of water for the rest of your life, you should be. Because the fact of the matter is you have no idea how much water you're going to have. First off, is a problem with lifespan. Some of y'all are not going to make it for another 70 years. Sorry. That's just the way it is. All right. Some of you may live past that, on this end, 120, or some modern miracle medicine to put you at, 250 years of age or something along those lines. So we can't know how, just the lifespan alone. But then there's, the days where you're like, yeah, I'm not drinking as much water today. Or I drank too much water, and now I'm bloated and unhappy and all this other stuff. The point is that you don't know how much you need over a period of time. So that amount becomes undefined. In economic terms, we would say that's unlimited. And so that's where that idea comes from. So that's scarcity. Now, why is it important? Because ultimately, if we have a limited amount of resources, to meet an unlimited amount of needs and wants, then ultimately scarcity forces us to make a choice. And that's why we're here. Economics itself, in general, as a basic idea, is to study a choice and how we satisfy our needs and wants. Because we can't have everything that we want. Okay? And if that sounds familiar, it's because it's a Rolling Stones song. And guess what? Mick Jagger, you know what his major was? He was economics, which is why the Rolling Stones are probably the greatest band of the 1960s, hands down, over the Beatles. Deal with it, live with it, accept it, and move on. Now, because scarcity forces us to make a choice, well, those choices come with costs. Before we get to that idea of opportunity costs, ask yourself this question, and it's a logic question. How many things are you choosing between at any particular one time? Okay. If you came up with this answer, that's correct. But the question, well, why is it two? Well, it's because what you choose and ultimately what you don't choose. That's what we're talking about here when you make a decision. And that's where opportunity cost comes in. The opportunity cost is the value of the best alternative not chosen. All right, and that's kind of the key idea I want you to take from that. But the key word in this definition is value. Okay, how do we measure the value of your second, best option, your missed opportunity, as it were? Well, think of it in terms of going to the movies. All right, at the movie theater there might be 20, 25 movies playing at any particular one time, and let's say that represents your entire universe of choices. Those choices, by the way, we call trade-offs from time to time. So you trade off one to go see another, that kind of thing. So let's say that you've narrowed it down, and you now have a choice between, say, Tenet versus Dune. All right. Now, one of these is going to be your choice. One of these is going to be your opportunity cost. So let's say that you choose Tenet, which means Dune is going to be your opportunity cost. Well, here's the thing about this, and this is what I want to make clear now. All of this, scarcity, opportunity cost, and the production possibility curve, it's always about the resources. And that's the most important part of this. So what resources are we talking about when going to see a movie? Well, first off, one of those resources is time. Okay? First off, Dune and Tenet are not going to be showing up on the same screen. You're not going to be able to follow both of them, even if they were. So you have to give up 2.5 hours to go see Tenet that you would have used to go see Dune. So that's one way to measure the value of opportunity cost. A second is money. Assume you didn't sneak your way into the theater. You had to fork over $10 to $15 to go watch a movie. Okay? Well, that's $10 to $15 that you used to go see Tenet that you now can't use to go see Dune. But the key thing for both of this, and this is really the important part, is that these are resources. These are resources we could have used to do one product versus another. Okay? Now that being said, now we can go into the production possibilities curve on this end. So let's do this with a new page. Now, the production possibilities curve is just simply a hypothetical model of two different types of goods. In like a textbook example, on one axis, it'll be consumer goods. On another axis, it'll be capital goods. It honestly doesn't matter which axis is on. It just is what it is. Now, a consumer good is just simply a good that you used up, non-durable goods. Think food, think clothing, think, some electronics, that kind of thing. Capital goods are more industrial. These are the things that we're going to use to make consumer goods on this end. All right. Now, here's the thing about this that you're going to want to kind of have an idea down. You want to be able to read this graph accurately all the time, every time. So let's do that. We're going to label this right here as point A, right here is point B, and out here is point C. Okay? So here's the thing about this, and this is one of the things that I want you to be able to do. The way you read this graph is going to be the same every time, but I want to emphasize something to you. It's not going to be about the math. It's what the math means, and that includes graphs. We don't care about the numbers, Again, we're social studies teachers. We're not always that bright, We want to know what the math means, and that's what I'm going to show you every time for this. So we can objectively read this correctly every time. So let's start off with point A. With point A, what we say for that is that it is efficient, okay? Now, the question is why is it efficient? Well, it's efficient because it's on the line. No. It's represented by a point on line, but that's not why it's efficient, and that's important, okay? Because the math is just representative of what this means. A is efficient because we've used all of our resources. And that's the only reason, okay? But that also tells you something else. If A is on the line and we use our resources, and A is efficient, well, then so are all these other points, okay? And in fact, any point along the line is going to be efficient. And that includes, by the way, let's mark this as, say, D, and mark this point up here as point E. If I'm at point D, I'm producing all consumer goods and no capital goods. Am I efficient? Yes, because I've used all of my resources. I'm making them all consumer goods, but I've used all my resources, so I'm good. Similarly, at point E, I'm making all capital goods and no consumer goods. Am I efficient? You bet, because I've used all of my resources. So any point along this curve is going to be efficient because we've used all our resources. Now, that brings us to point B. If A is efficient because we've used all our resources, then B must be inefficient because we have not used all of our resources. It is as simple as that. Okay. Another term you guys might hear for this is underutilization. But all underutilization means is that we're not using all of our resources. Now, this part is for macro students. Just FYI, when we talk about point B here, one of the things we have to look at is in terms of a national economy. We're not using all our resources, meaning we're not using all of our land, labor, and capital. Think about this in terms of labor. If we're not using all of our labor, then that means we have a higher unemployment rate. If we have a higher unemployment rate, well, that's going to be indicative of a recession. So if you get a problem with a PPC that asks about recession, well, then that's ultimately going to be a point inside the curve. So that brings us to point C. What's going on out here? Well, here's the thing. At point C, we're not producing too many resources or too many products. Logically, that doesn't make any sense. How can you produce too much of one thing on this end? Because remember, we use all of our resources up along the curve. So point C would ultimately be impossible. Another term you could come across here is unattainable. But more specifically, it's impossible or unattainable with current resources and technology. Does that mean that if we found new resources and new technology, we could ultimately, achieve that point? Yes, we absolutely could. Okay, and I'll show you how to ultimately do this. And I'm also going to add a third thing here. Trade. We're going to talk more about this when we get to comparative advantage, but it turns out that when ultimately countries specialize on things they're good at making and trade it for the things they're bad at making, ultimately they end up with more of both goods. So we'll talk about this. Now, here's a note for my micro students that I want you to start being aware of now. Now, this relates only to the PPC, but you're going to see these two terms come up again and again throughout the course. And those terms are productive and allocative efficiency. Now, when we talk about a productive efficiency, what does that mean? Well, point A here is productively efficient. Okay? So what we mean here for the PPC is that we've used all of our resources and therefore it's efficient. So how is that different from allocative efficiency? Well, to allocate something, is similar to the idea to distribute, but more specifically, it's to make a specific distribution. In other words, we're making a choice. So let's say that instead of at point A, we have decided to produce here at point F. Okay? F would be allocatively efficient. So the question is, well, why? Well, one, we've used all resources. And we chose this. So when we're talking about allocative efficiency within the PPC, what we're talking about is we are deliberately making a choice to produce at this particular point. And that point is also productively efficient. Come to another idea, okay? If you are allocatively efficient, you are also productively efficient. If you're productively efficient, you are not necessarily allocative efficiency. There is only one point on the PPC for allocative efficiency. So that being said, real quick, just for the macro students, this will come up in terms of economic growth. But let's say I have good X here and I have good Y here, okay? I want to show you how this curve can shift. If we find new resources, new technology, or something like that, then the curve could shift outward. But let's say that we enter a long-term recession or depression. If that's the case, the curve could shift inward, like this. But now, let's look at it in a different way. Let's say I find some new resource that allows me to produce more of good X than I was producing of good Y. Well, if that's the case, then how is that going to change? Well, in that case, you would just see one side of the curve change. And so that's one of the things we're talking about shifts, but this is representative of economic growth. And we'll talk more when we get to that unit. So one of the things with the PPC I told you is that it allows us to make a choice. Well, if we're allowed to make a choice, well, then that means we can ultimately measure opportunity cost. So let's say that I have an economy that produces nothing but chairs and computers. All right. So we're going to just do that. And let's start labeling points as A, B, C, D, and E. And let's draw in some ideas here for numbers. All right, let's say 2 chairs, 6 chairs, 15 chairs, and let's say that this is 25 chairs. Okay, so let's clean that up just a little bit. 25 chairs. Okay, and let's say on this side I have 4, 12, 25, 50. Okay, so this is essentially what I've got here on this end in terms of making some kind of choice between these. So how do I read this in terms of opportunity cost? Well, let's say that I'm here at point B, okay? And I want to go from point B to point C. Forget the airplane, I'm working outside, just the way it is. Apologize about that. So from point B to point C, okay, ultimately you have to ask these questions. What am I gaining versus what am I losing? If I go from point B to point C, I'm gaining 4 chairs, okay? So that's the first thing. I'm gaining 4 chairs. But if I go on this end, what am I losing? Well, 25 minus 12 is 13. So I'm losing the resources to make 13 computers. But I'm gaining the resources to make 4 chairs. So here's the question. What is the opportunity cost of these extra 4 chairs from B to C? And the answer is 13. I am losing the resources to make 13 computers to make these 4 chairs, which these chairs better be the most comfortable chairs you could possibly imagine. All right, so that is what it is on that end. Now, you can also go the opposite way. Let's say I'm going from point D to point B. Okay, so at D, okay, I'm at 4 computers and 15 chairs, and at B, I'd be making 25 computers and only 2 chairs. So what am I losing first? Well, 15 minus 2 is 13 chairs. That's what I'm losing. So what am I gaining? So that's 4 to 25. I'm gaining 21 computers. All right. Wow. I'm going to have to go inside to do these. Sorry about that. So if I'm gaining 21 computers, I'm losing 13 chairs. So that's my opportunity cost in this particular case, okay? My opportunity cost to produce those extra 21 computers is ultimately 13 chairs in that case. And this is going to be true if I was producing here at point E or point A. If I decide to produce at point A, then my choice is to make 50 computers. Okay? But my opportunity cost is 25 chairs. And similarly, if I were to go from A to E, my choice would be to make 25 chairs, and I would lose 50 computers. So that's how you read opportunity cost on this. But now here's kind of the last question that goes into this. Why is this line a curved line? Why isn't this a straight line? Okay. Well, first off, like I said before, the game is always about the resources. It's always about the land, labor, capital, and frankly, time. All right. So here's the thing about this. Let's do this on a different page. And let's say I have a hypothetical economy that produces, say, shoes and oranges. Okay? And I've decided that I want to produce more shoes, more oranges. Okay? We'll put this in terms of land, labor, and capital, our factors of production. All right? Well, if that's the case, okay, think about the natural resources we use to make oranges. Are any of the natural resources that we use to make shoes going to be, adaptable? Probably not. I haven't, tasted, shoe leather anytime lately, but it's not exactly the first thing on my plate. Similarly, the people that ultimately, make shoes, are we going to be easily able to convert them into the laborers we need to make oranges? Yes and no. It depends on the job. But ultimately, the resources aren't going to be, perfectly adaptable on that end. Now, think about the physical capital that I use to make oranges versus shoes. Am I going to be able to convert all those shoe machines into orange picking machines? Probably not. So, and also even the knowledge of, farming versus shoe manufacturing is not the same. The point of this is that there's going to be some resources going to waste, and that's going to be the key idea. Whenever you switch from one item of production to another, it's going to cost you more and more to do so. And this idea is called the law of increasing opportunity costs. The law of increasing opportunity cost states that when you switch from one item of production to another, it costs you more and more to do so. Why? The resources are not perfectly adaptable. Remember, the game is about the resources. So the resources that we have here to make computers are certainly not the same as we have to make chairs. So there's going to be some waste, whenever we switch from computers to chairs and vice versa. That's what the law of increasing opportunity cost tells us. Okay? But what if they were perfectly adaptable? If they were perfectly adaptable, your production possibilities curve looks something like this. It would be a straight line. Because in that case, the exchange would be even. There would be no loss whatsoever. X, all of good X, any of the resources I use for that could be used for all the resources for good Y. And that's it. But how realistic is that? Well, the answer is that it's not realistic at all. In actuality, a constant cost PPC is going to be a pure hypothetical, just to demonstrate the concepts of scarcity and opportunity cost. But it comes up. So just FYI, there it is. So that's pretty much it in a nutshell. If you have any questions, email me and we'll talk soon. Take care. Bye-bye.